lesson 1, and it's based on facial recognition with the use of fMRI. So first, what happens if I was in this part, or if I was participating in this study? What would happen is I would be shown 4 unmorphed faces. So it would be my face, my boyfriend's face, a random female who is 21 years old, and a random male who is 21 years old. I would see each of the faces for 15 seconds, and then each of the faces would be, they'd cut off the hair, the ears, and any non-facial attributes. So then they're gonna put the 2 pictures together and morph them. So the only pictures that would be morphed with my face is a female's face who's 21 years old. And the only face that would be morphed with my partner's face is another male who's 20 years old. The sex is kept constant, and the age is kept constant. So I'm going to be shown 21 pictures, and they're all going to be with a percentage that's combined. So it would be my face and this other female's face. And for example, it might be 20% my face and 80% the random female's face that I'd never seen before. Another example, it might be 65% my face and 35% her face. So if I believe that this face looks more like me or like my partner, I would press the right button. If I thought that it looked the right button. If I thought that it looked more like the random male or the random female's face, I would press the left-hand button. This would then be repeated 21 times, and this concludes the first part of the experiment.
Good morning, my name is Jordan Imhoff. I'll be explaining part 2 of this experiment. Part 2 was conducted 6 weeks after using a subgroup of 6 of the original 20 participants. They maintained the same basic design in the second part, and whereas they viewed each face for 15 seconds, and there were 2 different parts. The first part looked at morph faces for 2 seconds, and they consist of 70 to 100% known faces. The second part examined 7 faces of unknown self or partner counterparts. Controls were put in place to ensure maintenance of attention to the experiment, like here, when they looked at pictures of faces presented at 3.5 meters from each subject. There were 10 separate 30-second presentation phases that alternated between overlearned and novel stimulus. They wanted to ensure that the novel faces had become familiar by this point in the experiment. Participants were asked to identify whether stimulus is self, or partner, or novel. They determined this by pressing one of 2 buttons with the right thumb only, as quickly and accurately as possible. The entire process was monitored brain function with functional MRIs.
I'm Christiana Bianco, and I'll be explaining the results section of the experiment. In part 1 of the experiment, they analyzed the reaction time of faces that we recognize self or partner versus novel faces. For the results of this section, there was a significant reaction time for overlearned self or partner versus novel stimulus. In the contrast, there was no significant difference between recognizing self or partner. In the experiment, we analyzed the reaction time results via fMRI machine. Overall, there was 99.2 accuracy for identifying yourself or for identifying your partner. But there was no significant difference when responses were compared for 2 overlearned faces. For the fMRI machine, recognizing self versus novel faces, in parts of the brain, large cortical and subcortical networks were activated. In contrast, there was very little activation in the brain when you saw your partner versus a novel stimulus.
The study was done because there is little research done on facial recognition. Most researchers find it very difficult to separate it from face familiarity. These researchers in Germany tried to tackle this issue with the use of this study. The results answer this question of interest by looking at reaction times and the brain activity in recognition and the inability of recognizing faces. This study has taken a close look at the use of perception in recognizing faces.
Overall, this experiment, the authors did really well. It was really clear-cut and to the point, and there was no vagueness in the study. What they could have done better is they could have had more power. They didn't really use a big enough sample size, so in turn, having a bigger sample size could have changed the results significantly. any follow-ups that could be of interest, it'd be really interesting to cross-reference age. For example, use a group of 10-year-olds versus a group of 50-year-olds. Also, you could use patients with Alzheimer's to see their recognition through various stages of their disease. How does this work relate to other areas of cognition, cognitive psych or psych in general? Facial recognition is a failure of perception, which in the field of which is a field of cognitive psych. And also, how might this study be applicable in everyday life? Being able to recognize people you're familiar with and yourself is crucial in everyday life. Not being able to do that would make simple daily tasks nearly impossible.
This related article is called In Search of the Self, a positron emission tomography study, and this was published in the Psychology of Science. PET and other scans have shown memory encoding of self-stimulus processes are associated with left frontal regions of the brain. Retrieval of the self-process stimuli are according to the right frontal regions of the brain. For this experiment, 8 right-handed volunteers were chosen to look at images of self-stimuli versus novel stimuli to see what areas of the brain were activated. When retrieving the info of the self-stimuli, the left frontal regions of the brain were mostly activated. This correlates with the findings. This experiment, in turn, relates to the main article because when a person recognizes or sees a self-stimulus, more areas of the brain are activated than if you see a novel face.
A study titled Categorical Effects of the Perception of Faces done by Beal and Keel in 1995 was very similar to the original study discussed in this video. In this study, the researchers timed participants in the recognition of famous and novel faces. The participants were shown a total of 72 pictures of morphed faces at different percentages with blank screens between each. The results found that there was a significantly faster reaction time when the faces were of the famous people versus the novel faces. It was also a faster reaction time when the faces were familiar, even when they were morphed. The study was what Kircher and his colleagues based their study off of, with the use of self and partner faces rather than famous faces in the original study. The external validity of the experiment increases, and in turn increases the power as well.
Hello. In another related article titled The Contrast Polarity and Face Recognition in the Human Fusiform Gyrus conducted in 1999 examines the role of the fusiform gyrus in recognizing familiar individuals. Researchers used reverse contrast polarity of images while preserving edges and spatial frequencies. What they looked at was the combined influence of familiarity and priming on face processing as the contrast polarity was manipulated. Results from the fMRI show bilateral posterior areas in the fusiform gyrus respond more strongly to positive contrast polarity than negative contrast polarity. Also, anterior right lateralized fusiform region is activated when viewing a well-known face stimulus. Thank you for watching our video. If you have any questions, feel free to contact us via email. Have a good night.